How does a plate heat exchanger work? The plate heat exchanger is a very specific type of exchanger which has been available on the market for a number of years. It is an exchanger made up of, as the name suggests, several plates where the fluid alternates. The hot and cold fluids alternate. One plate yes and one plate no. That is, between a pair of plates, the hot fluid passes between the next pair, the cold one, then the hot one, then the cold one, and so on until the plate pack is filled. Normally, fluids move in countercurrent, so they flow in perfect countercurrent arrangement. And it is an exchanger that has exchange coefficients, if compared to those of the traditional tubular exchangers, much higher, therefore with a much higher thermal efficiency. This is due to the fact that the fluids inside the heat exchanger move in a turbulent manner even when the velocities of the fluids themselves are very low. Watch this video that I find very interesting. As you have observed, the fluids alternate between the pairs of plates as I mentioned, and they move in countercurrent. The hydraulic section of the channels, let's see if I can show it to you here. It is perfect. As you can see, the channels are very narrow. Let's say that the hydraulic diameter of passage is around 3 millimeters, 2.5, 3.2. It depends a bit on the type of exchanger, on the model of exchanger, but on average the sections are these. Additionally, taking into account the design of the plate, let us verify if I have one in my possession. Ah, here it is. The plate is designed in such a way that the channels are alternated with a herringbone design coupled in a rotated manner of 180 degrees. This creates a series of channels with a very small passage diameter of around 2.5 to 3 millimeters. The alternation and corrugation of the plates create a passage that is never linear, but forces the fluid into a motion that is continuously broken. This is the reason why even at low fluid velocities, there is turbulent motion due to the continuously broken motion caused by the plate design. The turbulent motion ensures efficient mixing and heat transfer, making it ideal for various applications in industries. Having a turbulent flow even at low speeds, the exchange coefficients are very high. This enables significantly higher thermal efficiencies when compared to other types of heat exchangers, such as tubular bundle heat exchangers, for example, or coil heat exchangers, for instance. And enables compact dimensions, but most importantly enables the plate heat exchanger to handle temperature differentials, thereby achieving a temperature of the cooled fluid that is close to the heating fluid, or vice versa, allowing for a very small temperature difference between the hot and cold fluids, which can even be negligible, resulting in a cooled fluid that can reach temperatures up to approximately 2 degrees lower. The temperature of the fluid is slightly warmer, with an increase of 2 degrees compared to the cooking temperature of the cold fluid. This is in contrast to other types of exchangers, like tubular bundle exchangers, which are practically impossible, or if possible, come with truly unacceptable costs and dimensions. It's an interesting topic, isn't it? I think I will explore it further and delve into the details to gain a better understanding.